everyone, welcome back to my channel. This is the 11th lecture of my data science series in which I will cover the topic logistic regression modeling. In this video, I will cover how to perform logistic regression using Python, how to perform Poisson regression using Python. Logistic regression modeling. What is logistic regression? It is a statistical method used for analyzing datasets where the dependent variable is categorical. It is one of the most popular techniques in the field of machine learning and data analysis, especially for binary classification problems where the target variable has two possible outcomes such as yes or no, true or false, or success or failure. Types of logistic regression. Binary logistic regression. The target variable has two categories. Multinomial logistic regression. The target variable has three or more unordered categories. Ordinal logistic regression. The target variable has three or more ordered categories. Advantages of logistic regression. Simple and easy to implement. Interpretable. Coefficients indicate the relationship between features and the target variable. Works well when the classes are linearly separable. Disadvantages of logistic regression. Assumes a linear decision boundary. Performance may degrade with high dimensional or highly correlated data. Sensitive to outliers. And another topic, how to perform logistic regression using Python. This is the step-by-step implementation to perform logistic regression. First, import required libraries. Second, load the preprocessed data. For this example, let's use a dataset with a binary target variable. Load the dataset, inspect the dataset, split into features X and target Y. Replace outcome with your target variable, split into training and testing sets. Third, create and train the logistic regression model. Initialize the logistic regression model, increase max ITR if the model doesn't coverage. Train the model. Fourth, make predictions. Predict on the test set. Predict probability of the positive class. Fifth, evaluate the model, accuracy, confusion matrix, classification report. Sixth, interpret coefficients. The coefficients provide insight into the relationship between features and the target. Get coefficients and feature names. This is the complete code for logistic regression. Load dataset, train, test split, logistic regression model, predictions, evaluation, coefficients. Another topic is Poisson regression. Poisson regression is a type of generalized linear model used to model count, data, and rates. It predicts the expected number of occurrences of an event based on one or more predictor variables. The response variable in Poisson regression is a count, and the distribution of the response variable is assumed to follow a Poisson distribution. Regression. First, standard Poisson regression. Models count data where the response variable follows a Poisson distribution. Zero inflated Poisson regression, used when the data contains an excessive number of zero counts. Negative binomial regression handles over-dispersion in count data where the Poisson assumption of equal mean and variance is violated. Further Poisson regression, similar to zip regression, but models zeros and positive counts separately. Advantages of Poisson regression. Suitable for count data, handles non-negative integer-dependent variables effectively, provides interpretable rate ratios for predictors. Disadvantages of Poisson regression. Assumes the mean and variance of the dependent variable are equal. If this is violated, the model may underperform. Sensitive to outliers and over-dispersion. Another topic is how to perform Poisson regression using Python. This is the step-by-step implementation. First, install required libraries. If you haven't already, install state models and pandas using pip. Import required libraries and import the necessary modules. Third, load and prepare data. For example, assume you have a data set where you are trying to predict a count variable based on some independent variables. Example data set: dependent variable, independent variable 1, independent variable 2. Check the first few rows of the dataset. Fourth, with Poisson regression model, use the formula API in state models to specify the model. In the formula, count feature 1 plus feature 2 indicates that you are predicting the dependent variable count using the independent variable feature 1 and feature 2. Fit the Poisson regression model. Print the model summary. Fifth, model predictions. After fitting the model, you can predict the expected counts for the data, make predictions, view the prediction alongside the actual counts. Sixth, interpret the coefficients. The coefficients outputted by the model are in log scale. To interpret them in terms of rate ratios, you can exponentiate the coefficient. This is the complete example code for Poisson regression. I have explained the topic logistic regression modeling. To understand other topics, stay tuned for further videos. Thank you so much.